Hey, hello everyone. I will start and thanks Wayne for speaking first. Thank you. Yeah, so hi everyone, I'm Gabrielle and I'm an open source contributor. Previously, I did speak a few times and I was at AWS as a solutions architect. So that was what I was doing last year. And then mid last year, I realized that there was quite a gap between AI software and hardware, where in the gap in the practice and understanding of AI. So basically at my day job, I was helping customers, super banks, digibanks onboard AWS, build infrastructure with AWS and build and machine learning things on AWS. But I realized that I didn't actually know what was happening under the hood. So when I say, oh, I want to deploy this machine learning model and I just click here, click there, ta-da, it's out. What actually is happening under the hood? How does the instances spin up? Why is there a shortage of GPUs? Why was every company in Singapore fighting over GPUs? And why is there a shortage of AI-ready data centers? So that led me to take a leap out of AWS to become an open source contributor with Homebrew. So just a quick pitch about Homebrew. It's open source AI research lab based remotely across Southeast Asia. And they are most known for this product called Jan.ai, JAN, which is offline ChatGPT. So that allows you to run it offline, let's say if you're on a flight or if you have sensitive data that you don't want to be going up to the internet. I'll cover that a little bit more later. But yeah, what I thought to share with us today is a very high-level overview of the racks and stacks of AI, what actually is happening under the hood. And so we'll go through this roadmap of what's in the model, what actually happens when you send a request. Second, what is the AI hardware that you're actually running your ChatGPT requests on from the GPUs to data centers. Thirdly, why is there a trend of local AI? And then lastly, hopefully we have time, I'll share some quick demos of what I'm pretty excited about in the trends of hardware and AI. So yeah, disclaimer, this is I'm not an expert in this technical, in this hardware aspect. I hired much more, or rather we have much more expert people who are doing the C++ coding on CUDA and all that. So this will just serve as a very high level introduction. And Homebrew has given more in-depth talks of this similar talk at Google and some of the local meetups. Yeah. So, okay, let's dive into what is in a model. So at a very high level, researchers close your eyes. We have the encoder and the decoder. So very simplified is that the encoder takes human language and turns it into machine readable language. And then in between, we have all these layers of neural networks. I'm sure you might have heard of the paper, attention is all you need. In short, just think of it as each of these networks trying to mimic your brain. And we have many layers, which I'll expand on later. And lastly, when we reach to the decoder level, it decodes all these numbers into what we want out as an output, which is the language and the next word prediction. So, how many of you have used Hugging Face or downloaded models from Hugging Face? Okay, great. So I see a few hands. So then I'll probably breeze through this. So we see that there are different types of models and the parameters. So for example, 3 billion parameters and 1 billion. What we can just think of is like how big the brain is. So the more parameters, the bigger brain it is. And these correspond to the number of layers there are. The next concept I want to share is that there's also the idea of quantization. So how many of you have downloaded a different quantization of the same model? Yeah, okay, lesser. So I stand as what quantization is. It's, for example, you see we have the 32-bit floating point. Those would be pretty large models. Whereas, and because it's so large, sometimes we want it to be smaller in order to run on hardware. So that's when we quantize it to become, for example, an 8-bit integer model. And so you can see for like, I copied this off Hugging Face. You can see that the F32 model is very big, about 32 GB. while the 8-bit Q2, or rather smaller, represents lower quantization. So Q2 is only smaller at 3 GB. So if this is getting, well, yeah, okay, let me get it. So all these leads up to that bigger parameters are supposedly more intelligent. But are they really? And so we see that with the scaling laws, actually it's not linearly more intelligent, but it does reach a logarithmic increase, where actually we are seeing that smaller models are increasingly becoming intelligent enough. They won't be as intelligent as the large ones, but they are being intelligent enough. And the last concept that I wanted to set as context is on memory. So these big models also require a lot of memory. Again, we see that it doesn't scale linearly, but it scales this time exponentially, where the large model, 70B, requires way, way more memory than the smaller models. So how does this all tie in when you decide which model to use? This second section is on what actually happens when you send your ChatGPT requests on a hardware level. And so this was, if this is slightly, or most of us, I think, don't think about this because we just see, we type in the text and then it comes out text and voila, but actually this is all happening under the hood. So when we say a prompt of, for example, tell me a joke, the first thing that happens is that the CPU makes a request, or makes a function call to get these model weights from the disk. And so just now, the layers that we talked about, those are the weights that are loaded onto disk. And then this is loaded into the CPU RAM. So we're on this side of the load model weight and initialize model. And then the CPU can decide to take the computation itself. Or it decides, hey, I have a GPU, which is much more faster. I should maybe offload some of the computations to GPU. So a quick primer on CPU versus GPU, in case anyone's wondering. GPU is much faster, because imagine if I had to take a paper and distribute it to all of you. I have two ways to do it, right? One is I take the stack and pass it to you, and then you pass it to the next person, next person, next person, and so on and so forth. That is similar to how the CPU would work. However, I could also split into a few different stacks and pass it across this way, and I have everybody passing down the row in parallel, and that's why the GPU computations are much faster. And that's why GPU has become important, especially for AI. So now we're at here where the CPU decides, hey, how much can I offload to the GPU? And this is one of the parameters that you can use in model tuning, NGL, but I wouldn't, and I'll move on from there. So lastly, we are getting, this is the last part of loading the model. Within the GPU, it's a lot faster. You can see it's about 700 GB per second versus CPU is only about 25 GB per second. And this model is now loaded onto the GPU. So that now we've loaded the model and we're going to move on into making the actual inference. So first, when the inference is, the prompt is given, the inference is loaded onto the CPU. And then we remember at the start, I said there was the encoder and decoder. So now the GPU tokenizes the words into embeddings. And then it executes the transformer layers that we saw, similarly just now, all the different layers up till it gets the prediction. And then it finally gives out the final prediction and the decoding onto the CPU. And that's how you get the next word predicted. So hopefully this is just a huge breeze through onto the hardware life cycle of an inference and how the model is loaded. So now that we've seen that, I'm going to just take a primer onto the AI hardware, which most of us sometimes we're excited about using, or now I think everyone's looking at which powerful computers you can use. NVIDIA just released their Digit supercomputer for about $3,000, you can have that supercomputer extend your laptop and your desktops. So why is that important? Currently, most laptops don't have a GPU. Unless you're really rich, then you have. So I think some people here have GPUs. And we also have some alternatives of, for example, the Apple Silicon. It has unified memory, which means that the GPU is not separate, but it does have some of the capabilities of a GPU. We also have Qualcomm's X Elite, which they are starting, people are getting pretty excited about with their Snapdragons. This extends into the AMD stack, and we are starting to hear a bit more about NPUs. These are just really great advancements in the AI hardware space. And what all this means is that there's going to be a lot of innovation for each of us consumers on the AI hardware level. And then we also have the desktops and workstations for those that want about 1 to 4 GPUs. And all these also means that just bigger and better, and you can do more AI. So now moving to where this links to data centers is that at a higher level, we have the servers. And this is usually, this just means it's a production level ready that can handle 24/7 operations. So they have all the pipelines, the measures, and the support for multiple CPUs. And fundamentally, it uses the better parts, for example, purer metal alloys, so that it ensures that they can be run 24/7. And then going to data centers, just quick question, who has been to a data center? Oh, nice. Okay, so yeah. So then in a data center, we have multiple servers into each of the data center racks. So last year, I also went for Security Week, where basically we were trying to find a data center that can run our GPUs. I'll talk more about the challenges there, but it's quite fascinating or exhilarating when you enter the GPU server room, and like you just, there's all the sounds from all the GPUs going and operating. And that is really when I realized, like, oh, wow, that is AI. Yeah, and that's what it takes to run AI. So the first challenge with hardware is that hardware is expensive and training is expensive. So this is a quick comparison. I won't go into the details, which were posted in a Reddit post, but basically someone decided to compare how much did it cost to train each of these models. So whenever we use, I'm using Llama 3.1b, all that kind of thing, did you know that it took about 1.46 million GPU hours and about 3 million to 6 million to train that model that you now have in your hands and you're using and chatting with it every day. So that is pretty mind-blowing, but also crazy that now we have all this power in our hands, but also this was what it took. This was the cost to train it. And therefore, for Homebrew, it's sort of a small group of tinkerers and hobbyists. They decided to build their own GPU rack, very homemade hobbyists, and just to make a comparison between the cost and also the memory and computation. So here we see that, for example, this simple home rack was 48 GB VRAM at $9,000. Which the cats unfortunately got into, and then it is now decommissioned. On the other hand, we also have this server rack, which is 640 GB VRAM at $350,000. I do not have that kind of money, so this is just a distant dream for us. And then, just to scale it out a bit more, then we have the multi-node GPU clusters, where we see that 20 TB is about 50 million. And so that is what all the big techs are pumping money and comparing each other to. I think today Times released an article saying like, yeah, all the Elon Musk, Mark Zuckerberg are all competing with each other. Who has the most GPUs? How big is my data center and how much can I pump into all of this? And so that is just the extreme scale of AI. But taking it back to where we are is that we realized our homebrew did some comparisons and calculations and realized that, hey, for the different GPUs that are offered with NVIDIA, here we see that for example, the same model that we're trying to train, we see that the more powerful models the more powerful GPUs, of course, take shorter time. And typically they are seen as more expensive. But if you actually add up the total cost of computation, given all the parameters of the GPUs and training time, it actually works out to be cheaper than using the A6000. So that was what we were hoping for, like, hey, let's get the biggest, most powerful GPU and just run it. However, there is a shortage of AI-ready data centers. So I think for those that have gone to a data center, okay, I'll go to that story next. But first, why the heck would we need to use a data center? Wasn't I from AWS and cloud computing? And yes. So in short, this is a quick calculation. All these prices are public as well. You have your typical cloud providers here, which is GCP, Azure, AWS. I don't know if anyone has heard of OVH or Hessner. Has anyone heard of them? Okay, great. So they are up and coming cloud providers that are quite popular in Europe and increasingly taking more market share compared to some of these cloud providers. And here we did a cost comparison. Oh, by the way, they have just launched in Singapore sometime late last year, so you can consider. Don't tell my previous teammates at AWS. But in short, there are all these cloud compute solutions, which we realize are great for burst compute, especially if you're using for very intense loads. But let's say for Homebrew, they decided that, hey, they wanted to gain the skills of running their own data center and GPUs for the skill sets, and as well as not the non-burst compute workloads, such as the day-to-day engineering, QA, app testing, app development. They wanted to run it on their own on-premise. So that began our hunt for which data center can actually host the GPUs. In short, Homebrew got the GPUs from Taiwan. And so they explored setting up a data center in Taiwan, which is running, and in Hanoi as well. But in Singapore, we really couldn't find any. And it was because of a power and cooling problem. So this was something I learned when I went for the Data Center World Conference last year. It was a Sijari week. They brought us to Batam, Johor, and Singapore in order to try to find AI-ready data centers. And the big problem was that most racks in Singapore are 6 kilowatts per hour, and that was sufficient to run the existing CPU workloads. However, in order to run the H100s, it needs 10.5 kilowatts per hour. That already exceeds the 6 kilowatt hour, and that is only one. Typically, they will put 4 of these, for cost effectiveness, they will put 4 of these in one rack. And so total, it needs about 45 kilowatt hour per rack, which is way more than what was available in Singapore. And so in short, most of the data center builders, we were talking to like DGS, Equinix, like a few other big names, as well as smaller data centers, were also trying to understand from the AI perspective, why on earth do you AI people need so much power? And we were also trying to understand, like, why don't you have GPUs for our data centers ready for us? And so that was a very interesting discourse and discussion between both sides, which there's a lot of room for innovation. So the good news is that I think Singapore now has about 2 or 3 AI-ready data centers. So the big names have gotten there, but there's no space for small teams or individuals like a research team. Yeah. The second problem is to do with cooling. And so with all these GPUs running, there's a lot of heat. And so currently, most of it is using either air cooling, which means, yeah, you enter the room, there's like the wind and the aircon, all that going to cool these supercomputers down. If not, it can catch fire. But there is a new trend towards liquid cooling, which a few AI data centers have already implemented or in production. And there's a third type of cooling, which is quite cutting edge. It is called immersion cooling. So that is where, nice, okay, yeah, exactly. Yes, yeah. So there's a few really cool researchers in Singapore who are both from the universities in terms of immersion cooling, where they submerge the whole server into this liquid that can more effectively remove the heat. The problem is that the servers are not, the warranty wouldn't stand if you dunked it in the water. Not water, but some liquid. And so there lies that whole ecosystem problem of how do we cool these computers? Are the chip makers willing to offer warranty? Where are the liquid cooling people? Where are the power people? And it's a whole ecosystem that needs to solve these interesting problems together. So that leads us to, okay, data centers are a huge problem that have yet to be solved. Let's explore on-device AI. So what can we do now just as with what we have, the hardware that we have right here? So that is, and why can we have a bit more hope in the current devices that we have? So how many of you have heard of DeepSeek 5.4? Yeah, okay, great. So this just came out today. These are the newest open source models that have been shown to be performing and excelling even beyond some of the closed source models like closed source models. So that was the premise that we had way back in July, where Llama 3.1 just came out. And that was the hypothesis that, hey, back then, early 2024, it was still the big text models that were still the best and the biggest and the best. But we placed a bet that, hey, the open source models will increasingly catch up, not just catch up, but surpass the closed source models. Okay. And secondly, combined with the factor of open source models, which all of you and I can run, we also have the hardware that can increasingly run bigger and better, can run models. So previously, we needed the GPUs, and that's why we were talking about all those GPUs. But now we have the desktops, and we have laptops, and we have phones. And later I'll show you on Jen that you can run some of these very performant models right now on your laptop without internet, just purely on your laptop. And so the point being, AI is going local, and as the hardware is getting better and better. So yeah, I'll show a few quick demos. I think I have some time for them. Here is where I would just like to share where I foresee this year where AI is going in terms of local hardware, as well as the expanded or cursory areas of robotics, embedded chips, which previously might have seemed pretty distant from all of us or abstracted from us. But I'm hoping to put forth that as one domain advances, suddenly with AI, it makes it very easy for the whole entire ecosystem to advance. So I'm going to share with you Jen. Jen, in short, is offline ChatGPT, and it has gained about 2 million downloads, monthly active users about 70K, and that's where we find quite a lot of niche users using it for their offline LLM use cases, as well as integrations. So we also have people building on top of Gen. So for example, this was a data camp blog post by Abid, where he showed how you can fine-tune your own model and post it to Hugging Face, and then download it onto Gen on your laptop to start using as your own customized model. And so AI is really coming into our hands and not just like off-the-shelf AI, but AI that you can customize and use as your personal assistant. Second, I'm going to share about Ichigo, which is our voice AI. Has anyone seen this talking strawberry before? Okay, good. Okay, let me stop sharing and start. Okay, okay. So let's share about Gen first. So this is Gen that you can download today. So it's on Gen AI. You can download it for your Mac. It's free, open source. The code is all on GitHub as well. So when you open it, what it offers is a lot of the models that you can download onto your computer. It recommends which ones are suitable or which ones are too big and might not have enough RAM. You can also paste any of the thousands or 10,000s of models that are available on Hugging Face that you can just download onto your computer. So I'm going to use this and okay, I can't turn off Wi-Fi because we're on the Google Meets call, but typically I would show that, yeah, all this is running on on off Wi-Fi, so just take my word for it. And explain thermal dynamics to, okay. Yeah. So you can see this is my Apple M1. It's running pretty fast, about 30 tokens per second. But if for those people with guns with GPU accelerated computers, sorry, I like to say very powerful computers, we have seen that it has gone up to 100 tokens per second, even more depending on your hardware specs. So that is Gen, and that's something you can use today already. Now I would like to share about Ichigo, which is also a model that Homebrew trained. So in short, it is real-time voice AI. This is also running on hardware. This is the web page, but sometimes we bring our demo where it's off internet as well and running. So what must I do in a fire? I should refresh it. What should I do in a fire? No. No, the follow. Okay. Semicolon Oh, no. Okay, bad idea. Yeah, okay, bad idea. I realized because it will echo towards. Okay. Uh, Okay, I didn't think this through, but in short, what this innovation was, this was released sometime last year. We could speak to it and it responded really fast, faster than most of the other real-time models, because the other real-time models were mostly doing text to speech and then speech to text. Whereas what Homebrew had trained was this model that understood the speech directly, natively as the speech tokens. So it didn't have to convert it to text, and that reduced the speed, the latency by about 13%. And so they are continuing to train this using building on top of Whisper VQ as well. And so this is quite an exciting, there are YouTube videos on, okay, let me show you. Okay, I'm going to find a YouTube video just to show you that it works. I can't, okay. Yeah, I can't turn on my computer volume, right? It will echo.
Here we go.
Yeah, okay, not a good idea. Okay, but yeah, in short, you can also see this blog post where all the training details are here as well. That is just one of the core philosophies of Homebrew, to train in public and train open source. Okay, next I'm gonna show, sorry. Okay, moving on to the third demo of how AI is coming to our hardware. This is a demo of how this guy used Gen to control his computer. So you can see here, he typed open a Chrome window, open a new Chrome window, and he linked it to this library called Open Interpreter. And so it has taken control of his computer and it's opening the Chrome window directly. Next, he types, tell Chrome to go to YouTube and search for Open Interpreter. And so the LLM is understanding it and then links to the Open Interpreter API, and it actually opens the YouTube video, searches for what he typed, and he found the video that he wants. And so all these can already happen on your computer. Like, can you imagine, so put the building blocks together. We have the voice AI, we have the computer control. Right now, theoretically, I can just talk to my computer and say, hey, open Chrome, open YouTube, search for something, play this something. And that is happening pretty soon, or it's possible. And so that's something those are things I'm pretty excited about. This. Sorry. I'm trying to go. Okay, great. Okay, and the last few demos I'll share. I'm mindful of time. Is that AI is going from software to physical. And so I think many of us have seen this news where NVIDIA launched last week that they are putting the digits Grace Blackwell on your desk. It's $3,000, and soon anyone with money can get a supercomputer that's running by their side. And so for all that I was talking about just now, where it was very complicated, all the data center supercomputers, now it has been made available and accessible to everyday users like you and me. The second thing they've also launched is also this Jetson Orin Nano, which is an embedded chip. And what this opens up is the whole realm of hobbyists and robotics who are now able to run powerful models on this tiny chip on whatever small hardware that they want, and that opens up the whole realm of smart devices. And so I just want to share this maybe two more robots, where how many of you have heard of Unitree or seen this robot dog? Okay, great. Yeah, so this robot dog, let me go to the side because it's a lot more impressive with their videos. In short, it can jump over like the chair height kind of thing. It can go up steps. And all this is available for $1,600. And it's running on the NVIDIA Jetson Orin Nano. Not Nano, sorry, Jetson Orin. And secondly, they also have this humanoid that is like pretty capable, not just of dancing, but doing like stuff and following humans, climbing up steps. And basically you have these humans walking around, right? And if this seems too like far-fetched to believe, I would just like to share this video that I have seen them in person. They are in Singapore and they are being used. So it's not too far-fetched. So this is my simple video. You can see the dog and the humanoids in the background. This is a company called Western Robotics that is reselling the Unitree robots. On their website, they've also shown some case studies. SPS is using it. Don't ask me why or like what the use case is. And a few other entities in Singapore are already using these robots, and they've been featured on the news, so on and so forth. So that is the really exciting. Okay, I won't play this, but the last one I wanted to share was that, yeah, imagine the building blocks of voice control. This guy, this is about a 1 hour long talk about how he uses voice control to control his drones. And so previously, perhaps drones might have been too complex for us to control, but now with voice AI and also the structured function calling, structured outputs, all these are actually soon reality and can become reality. So hopefully I've shared a high-level view of the breadth and depth of AI. I think we've gone through quite an exciting journey across the racks and stacks of AI. And so, yeah, the last thing I'll put out is that if anyone is curious who else is building cool stuff on AI, Homebrew does run this AI showcase that is happening tomorrow at NLB Bugis or Lee Kong Chian. So that's where we just give the platform to any company or people who are building interesting things on AI, and just quick 5-minute talks just to showcase what is the latest and greatest happening. So yeah, join us if you're interested. And yeah, that's it. Thank you.